Welcome to this very exciting video on the engineering analysis of Iron Man suit. On this channel Synergy Files, we aim to inspire budding engineers and technologists for a better, more sustainable world. In this video, we will dissect the famous Tony Stark's exoskeleton and will look at the possibility that with the engineering knowledge and the technology available today, can the suit be made? Coming up in this video, we will analyze the suit and look at it structurally and from the point of view of energy usage. That is, how much energy is used by the suit. And we will also look at the thermal management of the suit. Over time in science fiction, comics, movies, games, a wide variety of exoskeletons have appeared. These include the large mechas in movies like Pacific Rim and Avatar, to the nanosuits in the game Crisis. The Iron Man suit is a small exoskeleton that can be perhaps compared to the Mech-Prawn biosuit in the movie District 9. The Mech-Prawn suit was also a fascinating exoskeleton that had multiple high-tech features but lacked flight capability. In the Iron Man comics, there are several iterations of the suit that the character of Tony Stark has developed over time. Suits from Mark 1 up to Mark 46 have featured in the movies. All the suits have the following capability: external armor, supersonic flight capability, hovering capability, weaponry, decoy flares. The suit can be used for multiple roles, that is, it can be used for military offense, defense, search and rescue, and espionage. So let's dive into the structural or strength aspect of the suit. The suit is wear resistant and is also capable of absorbing shocks. The material required for such properties need to be extremely hard as well as ductile. Anomalous to its name, iron would not be able to cope with such extreme requirements. In the comics, iron platinum alloy has been suggested for the suit. In real life, the only thing coming close to Iron Man exoskeleton structurally would be titanium alloys. Titanium alloys are not only extremely strong in tensile strength but also lighter and therefore will provide fluidity of movement compared to any heavy material counterparts like steel. Having an outer hard material is alright to bear the brunt and provide strength against penetration. However, one must also consider that if the material is too hard, then any impact load would be passed on to the human body inside the suit. We have to remember that in automobiles, metal or composite body panels are deliberately made to crumple so to reduce the shock load that could be passed on to the human body inside the vehicle. But we cannot make an exoskeleton armor that would crumple, else its use would be just one-off. And therefore, the only way structural requirements cannot be compromised is by the use of an extremely soft material as an inner lining behind the titanium body panels. One material that is available and can be used on the inner surface is called sorbothane. Sorbothane is a synthetic material that is extremely soft and has the ability to convert shock loads into heat transfer at a molecular level. Even if one drops an egg from a high-rise building onto a bed of sorbothane, then this remarkable material is soft enough to cushion the impact and would not allow the egg to break. This technique of having an extremely hard material on the outside and a soft material on the inside is not new. It provides the best of both worlds in that the material is able to resist any penetrative load as well as any shock load. The outer hard material and the inner soft material method has been used for centuries, most notably in Japan for making samurai swords. The sword's hardness gives it the cutting edge and its penetrative power. The ductility of the sword allows it to absorb the shock loads when it strikes or is struck. Analysis of energy use. One of the features that makes the Iron Man suit unique is the hovering capability. Hovering using thrusters or repulsors as they're called in the Iron Man comics requires tremendous amount of energy, particularly when the suit is used over long duration. It should be noted that energy usage for hovering is dependent upon the method used for hovering. For example, magnetic levitation requires no energy at all but is limited to the presence of magnetic field. The next most energy efficient method for hovering is the use of ducted helicopter blade followed by open helicopter blade. Several human-powered helicopters have been made over time that have achieved flight. It has been experimentally recorded that using helicopter blades with a 78 kg person and a 55 kg copter requires only 1.1 kilowatt to climb and just 600 watts to maintain altitude. Hovering through jet thrust is one of the least energy efficient methods. If jet thrust is used, then over 1 kilonewton of thrust force will be required depending upon the weight of the jetpack and the person. This is because thrust to weight ratio should be above 1 for the jetpack to achieve liftoff. If wings are attached to the jetpack, then horizontal flight can be achieved with a ratio lower than 1, thus improving the duration of the flight and the range. As for hovering and flight capability, there have been jetpacks made in the past. Most iconic display of this came in the 1984 Summer Olympics opening ceremony. The fuel used in the jetpack was mostly hydrogen peroxide. Hydrogen peroxide provides thrust at a lower temperature, making the pack relatively safer compared to other fuels. Hydrogen peroxide, however, has a low energy density. Yves Rossi, more commonly known as the Jetman, has successfully used kerosene oil in his flights, but the thruster jets have to be pushed away from the body. His jet wingsuit allows him several minutes of flight compared to the jetpacks that have only managed up to 30 seconds of flight time. The point to note here is that even using energy-rich fossil fuels give limited flight time. If heavier suit is used that is greater than 25 kg, then hydraulics would be needed, which would require additional energy and would also slow down mobility. The Ironmonger suit was an example of hydraulic-driven mobility suit. In the comics, Tony Stark manages the suit's energy requirements, including running a thermal management system and an artificial intelligence system through the fictional arc reactor. The reactor is able to provide almost limitless clean energy despite being a very small device. In real life, the only thing that has an energy density comparable to the arc reactor and would meet all the energy requirements of the suit would be nuclear power. Note that uranium has an energy density of 80 million megajoules per kg. However, harnessing nuclear power in a suit that a human is going to wear is never a good idea, unless you are the Hulk. So let's look at more practical solution of battery energy storage technology. If lithium batteries are used with ducted propeller blades, then flight time in the order of minutes can be achieved. Furthermore, these batteries can readily power the suit's electronic requirements. Note that lithium battery packs have achieved energy density of up to 150 watt-hour per kg or 0.5 megajoules per kg. Fossil fuel, on the other hand, have a much higher energy density than batteries, but would require a clunky generator to power the suit's electrical requirements. There is a silver lining though, and that is lithium-sulfur battery. Lithium-sulfur batteries have 5 times more energy density compared to lithium-ion batteries. Lithium-sulfur packs have already powered the longest unmanned flight for more than 30 hours. Unless we discover something like an arc reactor, lithium-sulfur batteries could be just the thing to power up the suit. The downside is that it would take hours of charging for just minutes of fun. Thermal management. The suit cannot be hermetically sealed. Humans breathe out water vapors, and therefore ventilation is a must. Ventilation is also needed to maintain a good supply of oxygen. Therefore, there must be a layer of Gore-Tex along with vent holes to allow airflow. This will prevent any internal condensation to settle and will also remove buildup of body heat. The layer of sorbothane would act both as a thermal and an electrical insulator. Thus, when the suit would get too hot or too cold from the outside, that extreme heat or cold would not be transferred to the inner layer. There should be small fans to draw cold air from the ambient in controlled amount and should be able to expunge hot air. With the technology available today, the thermal management of the suit is easily manageable. There are also solid-state devices like thermal pads and thermoelectric generators. Thermoelectric generators can make surfaces hot or cold depending upon the polarity of the current and thus can be an integral component of the suit for controlling the internal temperature. Verdict: with today's technology, it is possible to achieve an exoskeleton that can perform a variety of operations. The US Army has already an exoskeleton armor called the Talos Project. Similarly, various powered exoskeletons have already been developed for medical applications. This includes the well-known HAL or the Hybrid Assistive Limb technology. For improving ergonomics, loading suits have been made similar to the iconic power loader from the movie Aliens. It is also interesting to note that the Koreans have already made a functional robot which allows the pilot to sit in the chest cavity. The robot mimics the pilot's action. This is similar to other mechas featured in the game Titanfall and the movies Avatar and Pacific Rim. So the good news is that the suit can be made with the technology available today but with limited functionality. It is the energy requirements that are the main issue and cannot be met to the level shown in the movie. If we look at the core reason why Iron Man has such a wide appeal, it is because there are legions of fans that believe that the suit is something that is attainable. And what is attainable is also something that is desirable. Thank you for your attention. If you found this video informative or entertaining, please do like it and share it with your friends. For more informative videos, please do subscribe to the channel. Thank you once again.